Okay, guys, so jumping into lesson 6.2. A big part of this chapter is being able to simplify radicals. I know this lesson says multiplying and dividing radical expressions, but as we go about it, we're going to have to learn to simplify radicals. So that's going to involve looking for those perfect squares or perfect cubes or whatever it is within the radical. So right up here, starting with, there's a few properties of radicals, and as we talk about these properties, we're multiplying and dividing today. What radicals can you multiply and divide? What radicals can you not multiply and divide? Notice what it says here. If the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b is the nth root of a times b. Okay, that is fancy talk for saying if they are the same type of root, you can multiply them. So you can multiply a square root times a square root. You can multiply a cube root times a cube root. Can you multiply a square root times a cube root?
No.
No, because their in values are different. It doesn't matter about a and b. It matters about their in values. And so I call those the roots. Officially, they're also called the index. So if you hear me refer to it as the index, so the root or the index. Same is true of division. If the nth root of a and the nth root of b are real numbers, then the nth root of a divided by the nth root of b is the nth root of a divided by b. That's just saying you can do a square root divided by a square root and put them under the same square root sign. You can do a cube root divided by a cube root, put them under the same cube root sign, but you can't mix and match. So no square roots with cube roots or cube roots with fourth roots or anything like that. Got it? So example 1 takes us very basic here. Can you simplify the product of the radical expressions? Explain. So, can I simplify the cube root of 6 times the square root of 2?
No.
No? I'm hearing no's. Why not?
Because they're different.
Okay. The in values aren't the same. They're different type radicals. Right here, I have a cube root. Is this one a cube root? No. What's the invisible number when there isn't one?
2.
That's an invisible 2 for a square root. And so the answer is no. It did say to explain. So I'm going to say, if I get official, I'm going to use the word the indexes. If you would rather say the roots, indexes, roots, however you want to say it, but they are different. And that's my explanation for A. Had nothing to do with the 6 and 2. It was all about that 3 and that 2. Okay, B. Cube root of -4 times the cube root of 2. Can I simplify that?
Yes. Oh, yeah.
I'm hearing some yeses, hearing some no's. What's the reason?
The root of 6.
Yeah. Both of my in values, my indexes, my roots, are 3s. So yes, we can. While I'm here, let's do the math here. What is the cube root of -4 times the cube root of 2? Yeah. You take those two, it stays a cube root. When you multiply a cube root times a cube root, stays a cube root, and -4 times 2 is -8. Okay, and I know it didn't say you had to multiply them out, but it's good to talk about it. Now, would I be done here? Yeah, technically, can we take the cube root of -8? Yeah, the cube root of 8, that's one we've talked about, isn't it? 2 times 2 times 2 is 8. So the cube root of 8 is 2. The cube root of a negative is a negative. Okay? Why? Because you're used to a square root, you can't have a negative?
Yes.
Yeah. And that's the deal. You have to remember 3 is odd, isn't it? And that changes the game. That's our game changer. 3 is odd, and so 3 negatives can multiply to be a negative, which is why it works. Okay, and C. The fifth root of negative 5 times the fifth root of negative 2. Can I multiply these?
Yes.
Yes.
Yes?
Yeah.
Why yes?
That's the index.
Because the root is there.
Okay. I don't care what's under the radical. They're both fifth roots. Whatever a fifth root is, right? We don't do a lot with fifth roots, but those are the same. So yes. What is the fifth root of negative 5 times the fifth root of negative 2?
The root is there.
Okay. So you keep the fifth root. Negative 5 times negative 2 is 10. Can I go farther with the fifth root of 10?
It's a decimal. No.
Okay. So officially, I mean, yes, there's always a decimal answer. But in terms of just simplifying this, like the variety without the calculator, and here's the deal, guys, because I know some of you are out there thinking, it's not 2. It's not 2. Because if the fifth root of 10 is 2, that means when I multiply 2 5 times, I'm going to get 10. Is that what's really going? No. 2 times 2 is 4, times 2 is 8, times 2 is 16. I just went bigger than 10. So it's not that you take 10 and divide by 5, right? That's not what it is at all. Now, good opportunity for me to just review. You guys remember how to do a fifth root on your calculator?
Yeah.
All scientific calculators will do it. For mine, I'm using this X root button right here. If I want to do a fifth root, though, I type 5 first. Then it's the X root. So that little X says I'm doing the fifth root of whatever I type next. If I do the fifth root of 10, well, yeah, there's an answer, but it's a decimal. Okay, there's always a decimal answer. So in this case, we would just leave it as the fifth root of 10. Okay, unless they say they want a decimal answer for some reason, we're not going there. Okay, you got the basics here? Those indexes are the same? Go for it. Multiply and divide. If those little in values are different, leave it as is. Okay, now, as we go into example 2, is this the one? I'm changing some of our powers today. So, first of all, on A, we're going to do a square root here. So, do me a favor, and I think I have a white, but pretend that little 3 isn't there. We're going to treat this as a square root. Okay, I'm changing the problem. There we go. And I want to talk about a square root here. What is the simplest form of each of the following? So what is the simplest form of the square root of 54x to the 5th? Do you know the square root of 54? Okay. If you ask your calculator the square root of 54, you get back in return a decimal. And when it tells me to simplify, I'm not looking for a decimal answer. Most of this chapter, I'm not looking for a decimal answer. Okay? So, with that in mind, what I'm looking for you guys to do, and I think you get this a little bit in Algebra 1, I'm looking for a perfect square that divides into 54. So 54 is not a perfect square, because there's not a whole number times itself that gives me 54. But I'm looking for what number that is a perfect square is also a factor of 54.
It's 9 and 6.
Okay. So why is 9? Okay, first of all, can we all agree? 9 times 6 is 54.
Yep.
That's agreeable, yes? Now, why do we have to pick that pair?
Because 9, the square root of 9 is 3.
Yeah, what do we know about 9?
It's perfect.
The square root of 9 is 3. So, I mean, 54 is also 2 times 27. Could I use 2 times 27? No. I'm looking for a pair that has a perfect square. And that's the challenge we're going to face. Is, okay, how do we find that pair? Now, and we're going to talk about that. But 54 is 9 times 6. And what I'm just doing right now is I'm kind of doing my work. I'm breaking it up. 54 is 9 times 6. Now, we got to talk about these x's. We learned this yesterday. Can you take the square root of x to the 5th? And I guess I should back up and ask, do you remember how to take the square root of an exponent?
You divide.
Divide it.
You divide it by whatever your power is. In this case, I'm doing a 2. Does 5 divide nicely by 2?
No.
No. So we also have to break our x up. Now, what I'm going to say is 5 does not divide nicely by 2. I want the closest number below 5 that does divide by 2. And the closest number below 5 that divides by 2 is 4. So we're going to break this up into x to the 4th. And then how many x's do I have left over? X to the 1st. I've rewritten this, but I hope you can agree this problem is still the same problem. 9 times 6 is still 54. X to the 4th times x to the 1st is still x to the 5th. What I did is I broke it up into perfect squares that I can take the square root of and the leftover pieces, the pieces I can't take the square root of. Okay, so what we're ready to do here, if it helps, I can put that there. We're going to look at each piece. We're either going to take the square root and put it outside the square root symbol, or we're going to leave it under the square root symbol if we can't take the square root. Okay? Question?
Yeah, is there supposed to be an addition sign between the two x's or no?
No. The property here that we need to remember is when you multiply x's when the base is the same, the shortcut is to add the exponents. So it is multiplying x to the 4th and x to the 1st, but the shortcut is to add the 4 and 1. So I'm not actually going to write an adding sign. You just have to kind of know that part. Okay? Okay. Square root of 9. Do we know it?
3.
It's 3. So my 3 is going to go
Oh,
out front. It's no longer under the radical. It is just a whole number 3. Square root of 6.
square root of 3.
Do you know it?
Yes.
Square root of 6 is a decimal, right? So 6 is going to stay under the square root. Okay? Square root of x to the 4th. Do I know it? How do I do the square root of x to the 4th? You divide it by this little number right here, yes? And when you divide 4 divided by 2 here, we're going to get x to the 2nd. So does my x to the 2nd go outside or stay under? We're taking the square root. And so x to the 2nd is outside. X to the 1st. Can I take the square root of x to the 1st?
No.
No. 1 does not divide by 2 and give me a whole number, does it? So x to the 1st is going to stay under the radical. I just wrote x. I don't need to write the 1st, but you can if you want. And here we go, guys. Final answer. 3x squared times the square root of 6x. You are done if and only if there's no perfect squares left under the radical. I can't take the square root of 6. I can't take the square root of x. I'm done. Okay? Questions on this one? Obviously, this is just the first example, right? We're going to do more. I'm going to explain more if you're a little foggy. Now, let's look at B. B, we're going to work with this as a cube root. I'm not changing this one. Okay? I want us to practice square roots and cube roots. I think homework does a lot of square roots, but we need to be comfortable working with both. So now, last time, what perfect square is there in 54? Now, this time, we're not talking squares, we're talking cubes. So what perfect cube is there in 128? Do you know your perfect cubes?
No.
I didn't think so. I only know mine so far. So I have a helpful paper to give you. And while I'm handing these out, if you need to stand up and take a quick stretch break and wake yourself up a little bit, go for it, because it's very warm and cozy in this room. Which yeah, not surprised. Okay, this blue paper is a helpful tool. Guys, guess what? You get to use it on your test and quiz in this chapter. Okay, it is that helpful for you. Some of you may get to the point you don't need it. You may be like, yeah, I got this, piece of cake. But this is how I teach this chapter.
I forgot to ask, do I need to make up the pretest?
I think I probably will. I'll probably have you do it in homeroom.
Okay.
So if it wasn't your first day back, I probably would have grabbed it today during homeroom, but I was like, I'll probably have you do it during homeroom someday. Okay. Okay. Between this blue paper and the calculator, that's the tools I use to teach this. Now, you guys realize what's set up here? As we go back and look at the squares for a moment. Square root of 4, square root of 9, square root of 16, square root of 25. You notice what order those are going in? What is the square root of 4? 2. What's the square root of 9? 3. What's the square root of 4? 16. You guys knew where I was supposed to say. Square root of 16 is 4. Square root of 25.
Right.
Notice that first column goes from 2 all the way down to 10. Take a guess. What's the square root of 121 if you don't know it?
11.
11.
Well,
Do some math. Can you figure out all the rest of these?
20.
Yeah. You have this second column is 11 all the way down to 20. You are welcome to write on this paper in that. If you want to write what they each equal, you can. They go in order. So you're going 2 through 20 on your squares. I just don't write it on there because I don't want to confuse you with extra numbers. Okay? Now, the reason I'm really handing this out right now is the cube roots, isn't it? So look at your cubes. What's the cube root of 8? 2. Maybe you know it, maybe you don't, but what's the cube root of 27? 3. What's the cube root of 64? 4. Cube root of 125? 5. Cube root of 216? 6. Are you catching on? 7, 8, 9, and 10. So you're more than welcome to write what each of those equal. Occasionally we'll use fourth roots and fifth roots. Not as often, but we will some. Take a guess. What's the fourth root of 16? 2. What's the fourth root of 81?
4. Oh, 3.
3.
What the heck? Where did I get 4?
The fourth root of 256?
4.
4. And the fourth root of 625? 5. You could make this list bigger if you wanted to, but I just, tried to do some basics. And what about these fifth roots? These are going to equal 2, 3, 4, and 5. So you see how my blue paper is set up, yes? I tried to make it easy. Okay. So, all of that. We're going back to example B.
Okay.
Here's how I use the blue paper. I want cube root of 128. So first thing I'm going to do is I'm going to go to my cube root column. Is 128 on my list?
No.
It is not on my list. So 128 is not a perfect cube. And my calculator will confirm that, right? Now, what I do is I look at the numbers. Okay. I look at the numbers. 128 is not on the list. So I want to see, does 128 divide by any of these numbers here? So I take my calculator, and I'm going to try. I usually start right there, unless I see something. Does 128 divide by 125? No, because I got a decimal. So then I move up to this one. Does 128 divide by 64?
Yes.
Oh, hey, guess what it does? So that right there is my perfect cube that goes into it. And that's the largest perfect cube. That's why I always start there at the top, because I'm trying to start with my largest number. So, how do I use this then? $128 is not a perfect cube, but what divided into 128? 64, and how many times did it go? 2. So that's why I'm writing 64 times 2 under my radical. See this blue paper being helpful alongside a calculator? Okay. Now, x to the 7th. Can I take the cube root of x to the 7th? No. I cannot take the cube root of x to the 7th because 7 does not divide by 3 this time. So what is the closest number below 7 that divides by 3? 6. So I'm going to take this and I'm going to break it into x to the 6th. And what's the leftover? X to the 1st, or x. Okay. So now I'm just ready to break it out. Can I do the cube root of 64? Yes, cube root of 64 is 4. So I put a 4, that goes outside my radical sign. Can I do the cube root of 2? No, so what's it going to do? It's going to stay under the radical. Can I do the cube root of x to the 6th? Yeah, what do I do with 6? Divide it by 3. And 6 divided by 3 is? X squared. Does x squared go out or in? It goes out. Can I do the cube root of x to the 1st? No. 1 does not divide by 3, so x to the 1st gets left underneath the radical with the 2. And there we go. Okay. Ask questions as we go if you run into them. I feel like a lot of you are following. Ready to try some multiplying then? My opinion is going to, and there's different ways I could teach the multiplying. Okay. We talked up top, in order to be able to multiply, they have to have the same index, right? They have to be the same root. Other than that, that's the main thing. I could teach that we simplify each of these and then multiply, or I can teach that we multiply and then simplify. The key is, this simplifying steps I just taught you up here, we're going to have to use them in our multiplication problem. Now, I personally choose to teach multiply and then simplify. If another, a tutor or another teacher or someone helps you and they do it a different way, that's fine. There are different orders you can do this in. It's just how I choose to teach it as a whole. Okay? So, first of all, can I multiply these radicals?
Yeah.
Yeah, they're both square roots. So let's multiply them. Multiply like pieces. 72 times 10, 720. X to the third times x. Add those exponents, x to the fourth. Y to the second times y to the third. Add those exponents, and it's y to the fifth. Now, you've multiplied. But the key is they ask us for the simplest form. So now we're going back up to what we did up above. And we're going to simplify. So my question to you, is 720 a perfect square? And here's, how you check. I mean, I guess, is it on your list?
No.
Well, actually, my list doesn't go that high, does it?
No.
It doesn't.
And you can make your list higher, as I said, if you wanted to. But my list doesn't go that high. But, so I can do square root of 720, and I get that decimal. Now, let me use this moment to say, if your calculator gives you something other than that decimal right now, just know right now I'm going to ban your calculator on my test. Okay? So, because that means there's definitely a mode that will simplify that. If you have a radical in that answer, that the square root of some 720 is something times a radical of something else, yeah, no, I won't allow that calculator. Now, for the rest of us, 720 doesn't work. Okay? Yeah, I know John's does. John knows the final answer to this problem depending on the setting he has his calculator in. Now, and here's what I'm going to say. I'm picking on John just because I saw his calculator yesterday. Okay? John can use that to help him on homework, yes?
Yeah.
However, does he want to rely on that?
No.
No, because then he's not going to know how to do it for the test, right? So that's something he can use as a helpful tool to check himself. But he still has to know how to do it for the test, as we all do, right? So just if you have access to a calculator that simplifies, don't rely on it, because then you won't know how to do it on the test. Okay, 720. Didn't work. Here's what I do. And you can kind of tweak this, but I start here and I start with my biggest number. Does 720 divide by 400? Nope, I got a decimal. Does 720 divide by 361? Nope, I got a decimal. Does 720 divide by 324? Nope, I got a decimal. Are you seeing where I'm going with this? 720 divide by 289. And you also see now why I said have a calculator by your side, didn't I? 720 divide by 256. Keep going. Find one that works. Hello. Okay, I will let him know. Bye. Trevor, I'm guessing you don't need it right now, but they have found your bag and it's in the office.
Yeah, I had it placed in the movement.
Ah, okay. Well, Christy just called. She has it. You'll want to get it from her later.
Thank you.
Okay, have you guys made any progress?
Yes.
Yeah.
I mean, I can keep going here. You guys can tell me where I need to jump to.
144.
Okay, see, I'm almost there. I'm at 196. You're going to tell me 169 doesn't work, so I should just go ahead and say 144?
Yeah.
Okay. That works for me. Help each other, help us out there. This is why I'm going to say you want a calculator, right? Because that's a lot of work otherwise. Okay, so we're going to take this radical now. We know that 720 divided by what perfect square? 144. And it was 144 times what?
5.
144 times 5. So I put those under the radical. Okay, my variables. Does x to the fourth Can I take the square root of x to the fourth? Yeah, because keep in mind, what's the number that 4 has to be able to divide by? There's an invisible 2 on this problem. So x to the fourth, I'm not going to square root it yet, just because that's not what I'm doing in this step. I'm just going to leave it as x to the fourth, because it will take this, I'll be able to take the square root of it just fine next step. Can I take the square root of y to the fifth? No. So, you know the question I'm going to ask?
Yeah.
Closest number to 5. So let me rephrase that. Closest number below 5 that divides by 2. And that's 4. So I'm going to break this y into y to the fourth and y to the first. Okay. Square root of 144. 12. It's going to go out front. Square root of 5. As in it's square root of 5 still, so it's going to stay under my radical. Square root of x to the fourth. 4 divided by 2 is going to be x to the second. That's going out front. Square root of y to the fourth. 4 divided by 2, y to the second. Square root of y to the first. It stays as is, and it's going to be a y to the first or a y under my radical. Okay. What John's calculator did is it told him that the square root of 720 is 12 square root of 5, depending on the setting he had it in. Okay? So, helpful in a way. Helps him maybe learn it, but we still have to know how to use it. Okay? Questions? Are we starting to catch on? Okay, let's go ahead and do B. And if we can get through B, then that saves dividing for tomorrow. Sound good?
Yeah.
Okay. My first question. Can I multiply these?
Yeah.
Yes, because they're both
Same root.
square roots. So, multiply away we go. What is 45 times 35?
1,575.
Lovely. 1,500 and what? 75, sorry. X to the fifth times x. Add those exponents, x to the sixth. Y to the third times y to the fourth.
Y to the seventh.
Add those exponents, y to the seventh. Okay. Again, I told you have a calculator by your side today, didn't I?
Yeah.
I don't know how you're, unless you are just a super duper math whiz, I don't know how you're getting that one without the calculator by your side. Now, we only have up to 400 here, but that's all right. As you start dividing, I'll be honest, I know it's not going to divide by 400. I know it's not going to divide by some of these just by looking at them. If it ends in 75, could it maybe divide by 225?
Yes.
Yeah.
Yeah, so if you haven't jumped there, there's a good jump. And here's the nice part. It divides by 225, and that leftover 7 does not have a perfect square. So that's a good news. And if I have time, I'm going to show you one other option of what sometimes happens. So, okay. 1575. I am rewriting it as 225 times 7. If you're someone you're saying, but I used 1575 divided by 25 because I saw 25. You can make that work. And I'll show you that option here in a moment. This is just the option I prefer to teach. What about x to the sixth? Am I going to be able to take the square root of x to the sixth? Yes, because 6 just has to be able to divide by 2 because we're talking square root. So, I don't need to break it up. Y to the 7th. Can I take the square root of that?
No.
No. 7 does not divide by 2. Closest number below 7 that divides by 2. 6. So that's going to be 6 and 1. Y to the 6th, y to the 1st. Are you a step ahead of me? Some of you are. Some of you are still trying to figure it out. Okay, square root of 225.
15.
15. Square root of 7. It's going to stay square root of 7. Square root of x to the 6th. 6 divided by the 2 is x to the 3rd. That's outside. Square root of y to the 6th. 6 divided by 2 is y to the 3rd. That's going outside. Square root of y. 1 doesn't divide by 2, so y stays under the radical. Now, if you would, and you don't have to write this down, but a side note real quick, okay? Because I want to kind of mention something. 1575, right? As a class, I encourage you to go for the biggest number you can, which is 225. Now I want to play the what if game real quick. What if you didn't see that 225 worked and you used 25? Well, it's 25 times 63. Okay? Here's the catch with this one. 25 is a perfect square, isn't it? But the problem with 63, 63 still has a perfect square in it. So the key is if you don't use the biggest number, you have to keep going. So I'm going to keep 25, but what does 63 divide by that's a perfect square? It's what? 63 is 9 times 7. I'm moving this along because I know we're going to have to leave soon. Here's the deal. Square root of 25 is 5. Square root of 9 is 3. Square root of 7 is still square root of 7. And what's 5 times 3 here? 15 square root of 7. Did I still get the same numbers?
Yeah.
Yeah, I just dropped out the x's and y's because I didn't need to redo the x's and y's. So my point is, if you don't grab the biggest number, that's fine. Just know that you have to look for other perfect squares along the way. Okay, homework should be out there and available. I would strongly encourage you to practice and try the multiplication problems tonight. I would stay away from any division until we talk about that tomorrow, but you can go ahead and try multiplication. And we'll come back and talk division tomorrow.